Okay. Good afternoon, one and all. Science is poetry of reality. Welcome to Challenges and Opportunity of Science Education virtual talk in collaboration with Gravity Science Foundation. I am Supriya Nayaka, your host for the session. Today, we gathered here to explore significance of challenges and opportunities of science education. Before that, I like to brief about Creactive. Creactive is a group of people who are eager to gain new knowledge. Cre means creativity, active means activeness. Creactive means to be active, we need creativity. Creativity keeps us active. Knowledge Square is our tagline. Sharing of knowledge increases our knowledge. Creactive vision is to bring constructive thinking on various domains. And we mainly focus on non-textual, non-academic, non-syllabus related concepts. Every Saturday, we organize online talks, online weekend talks on Zoom platform, and we live stream our program on our YouTube channel, Creactive GBD. We are very thankful to all our resource persons for engaging us with their knowledge. Science education plays a vital role in our society shaping our understanding of the natural world and the principles that ground it. The society that understands the importance of scientific advancement, values evidence-based decision making, and actively engaging with the scientific discovery that shapes our world. Throughout this webinar, we will explore more insight things about this topic. To present this session, we have young and energetic speaker, Mr. Abhishek sir with us today. I call Mr. Govardhan, Creactive volunteer, to introduce today's speaker. Over to Govardhan.
Thank you, ma'am. A very good afternoon to everyone. My name is Govardhan. It is pleasure to introduce Abhishek sir, hailing from Alur village in Chamarajanagar district. He is a science communicator, educator, visiting professor in physics and science promoter in rural areas of Chamarajanagar, Mysuru and different parts of Karnataka. To popularize basic science among students as well as in general public in order to promote basic sciences among school and college students, he started to serve in the field of science since 2012 and has visited hundreds of schools, colleges, and delivered many science lectures and conducted science programs for the scientific community. He has reached thousands of students and demonstrated many experiments in the remote areas of Karnataka and motivated tribal children also. Abhishek sir received several awards including the National Youth Icon National Award, Young Scientist Award from KRVP, KRVP, Kirti Shri Award, Karunada Ratna State Award, Basavajyoti Award, Innovative Teacher Award and State Award given by the Department of Women and Child Development, Government of Karnataka, from the Honorable Chief Minister of Karnataka. He is a live member of professional bodies like Indian Association of Physics Teachers, KRVP, etc. Thank you, sir, for coming and welcome to this session. Thank you.
Thank you, Govardhan. Over to Abhishek sir.
Thank you. A very good afternoon, all of you. Really, it is a great opportunity for me to express my thoughts and views on science and science education. And before going to my lecture session, really, I would like to appreciate the efforts taken by the team, Creactive, in creating the awareness among the general public, students, and teachers community about the science and technology. As mentioned, today's topic is the challenges, opportunities, and importance of science education. Myself, as introduced, Abhishek K.S., I am working as an assistant professor in physics and also the founder, secretary of Gravity Science Foundation from Chamarajanagar. Okay. Before going to my exact lecture, let us salute the great minds of the nation who have contributed a lot towards the development of science and technology in our nation. So, as a name indicates, scientific method in my title, but first you need to understand what is scientific method. Before going to study the science, there is a standard method in order to understand science. Hello, am I audible? Am I audible?
Yes.
Hello. Okay. Thank you. The scientific method is very important. There are some steps in order to understand science. This is a general idea that what I have mentioned in this slide. So the first thing is that the careful observation of the natural phenomena, because we have to observe the nature. That culture we have to locate is starting from the students, teachers, all among the general public also. I request other participants to please mute your audio.
Minute, sir. I'll mute. 1 minute. Sir, you unmute yourself, sir. Abhishek, sir.
Okay, ma'am. Fine. Okay. Okay. Shall I continue now?
Yes, sir. Yes, sir. Yes, sir.
Okay. There are some method in order to understand the science. As I mentioned, the first method is that the first step is that nothing but the careful observation of the natural phenomena. Because if we are not going to observe the nature, because nature is science. As we know, the systematic study of the nature is called science. So we have to observe the nature. Then only we can understand the many miracles and the things which happen. Children also, what I suggest is that you have to observe the nature, because something in the night sky is moving. You have to observe it. What kind of object it is, and some animals, or the way the animals are eating, the way the birds are flying. Those are all the sense. Those are all the ideas. Those are all the observations are very important for understanding the science. So that is the first step. The next one is formulation of rules and empirical laws. That means what are this in a simple term. Let me explain it. Just what are the observation you are going to do, just to make a short note of it. So based on that observation, you have to compare your observation with the existing hypothesis and theories. That is nothing but our third step. That means what are all the observation you are looking in the nature, that you have to make a note and compare those observations with the available resources, because nowadays, because of the development of the technology, we will be having many resource materials. So just go through that and compare your observation and get some ideas, get some information about your observation. Then you compare it. Then you will come to know what all the right things are there, what all the corrections are you need to do. Those are the things you can easily understand once you study it. That means that is nothing but the refinement of that's what I have mentioned. Development of hypothesis to explain the observations and empirical laws, and the refinement of hypothesis into theories. And the last step is experiments. Science is nothing but experiment. If you are not going to do the experiments, definitely you are not going to understand science. So science is completely based on experiments. For example, even the Nobel Prizes are given to the people, those who have explained the concept in both the ways, theoretical as well as experimental. So the concept, what you are studying, you have to have the better picture in both the ways. One is experimental and the one is as well as theoretical. So the important part in science is that doing experiments. So what are the observation you are doing, just experiment it. That is one of the very important method you need to follow in order to understand. This is not the rule. This is the particular. This is the must requirement you need to follow. No, I'm not telling that like that. These are all some important points you need to remember when you are studying science. Okay. Some points I have mentioned here. That is the secrets of success in studying science. As I mentioned in my last slide, that is the experiments. You have to do the experiments and get the good picture. Get the good picture in the sense. For example, let me take one example. The force of attraction, which is which is there between the Earth and the Sun, is gravitational force. That you know. The same force is acting between any two people, right? So you have to get a big picture. The same force is acting between any two objects you can consider on the Earth. The same force, the same kind of force which is acting between the distant objects. That's as I mentioned, the moon and the Earth, the Sun and the Earth. So that means whatever the concept you are studying in science, you have to try to get a big picture. That means wherever we can apply it, you have to study that. And one more important point, explore questions. Yeah, that is very important, because if you can't question, if you there must be some question in your mind, that if you read that concept on that basis, you can get many ideas. Maybe you come with some wonders in science. That's why explore questions is also very important. And try the exercise. If you are not going to practice, if you are not going to revise your ideas, if you get one idea, for example, today if you are going to get one idea, you have to exercise it and you have to revise it. Otherwise, tomorrow you are going to forget it. And be there, because once you started some topic to study, you have to, there will be a continuity. Otherwise, definitely, if there is no continuity in science, definitely you can't understand the complete picture. And one more thing is ask questions. Whether definitely we can't give 100% answers for all the questions in science, but at least if we ask some questions, definitely we will get more better understanding about some particular topic in science. And review your understanding. That is very important. How can you review your understanding? The better way is that what are the concepts you are going to understand, just to explain the same concept to your friend or to your teacher. Nothing wrong if you discuss the concept with your teacher. So that is one of the very important things, is review your understanding. What is your understanding level? Then if you review your understanding level, then you will come to know that, yes, this is this much of concept I have understood. What are the rest of the things I need to go? Those are the things you will get it. So that's why these are some important points what I have observed in students as well as the teachers. So experiment, get the big picture of any scientific concepts, explore questions, try the exercise, be there, that there must be a continuity. Ask questions, you have to enter. That's what we can call it as a scientific attitude. That must be there in the science person. So review your understanding. These are all some important points. So if you look into the status of human life during 1800, see, during 1800 there was no railways, power ships, telephone, radio, televisions. Yet nothing was there. Nothing was there. There's no scanning machines of like NMR, X-ray. No, nothing was there during 1800. But the situation during 200, within 200 years, changes are unimaginable. Because how did it happen? All this are due to the development of science and its principal practical application through technology. That is very important. See, these are all the changes is because of the development of the science and technology in these 200 years. The basic things is that the discoveries and invention in the basic science like physics, chemistry, biology, and mathematics. So, as you know, mathematics is a language of science. So that is also very important. And one more thing is that first you need to understand the differences between discoveries and inventions. Discoveries means is finding something new, which already exists in the nature. But invention is nothing but you are going to create something new. That is invention. For example, transistor is an invention. For example, television is an invention. But if you find the moons of the Saturn, it is a discovery because it is already exists in the nature. So technology developed using this result, this discoveries and invention. So that's why that's technology is nothing but you are going to apply the scientific principle in order to help the society. So as I mentioned here earlier, this is nothing but that the science of today is the technology of tomorrow. That in a simpler way, today's science is tomorrow's technology. And first, you need to understand the difference between science, engineering, and technology. Science, as I mentioned, you need to understand the principle laws which is there in the nature. First, you have to observe the nature, as I said. So if you observe the nature, you will come to know most of the miracle things which is happening in this nature. So first you understand, get the knowledge of general truth and the laws and principles of the science. So that is nothing but science. If you want, for example, Newton's laws of motion. So Newton's laws of motion or Newton's laws of gravitation, these are all the law which is happening in the nature that we need to understand the mysteries of the nature. That is nothing but the science. As I mentioned earlier, you can also say that is a systematic study of the nature. We can call it science. And one more thing is that engineering. Engineering, acquiring and applying the scientific knowledge, what you are understanding through the scientific laws and the principle, you have to apply it to build and design, create something new. As I said, that is engineering. And the sum of all engineering tools, devices, processes available. That means converting that scientific principles and ideas of engineering into the application part, that is nothing but the technology. This is the difference between science, engineering, and technology. So now in my presentation, just what I am going to do is that in the beginning, just I am going to explain the applications of the basic sciences, because once after completion, even for the PU students, once after completion of their PUC, they are just looking into the medicine part, or whether it may be into the medicine or maybe into the engineering. So other than that, also there are many opportunities for the basic science students, that any particular student is going to complete his PUC. There are a number of opportunities in the basic science research. So in order to make that point to understand, I have chosen some topics in the field of medicine as well as in the technology. I am trying to explain the basic science behind it in my presentation. So let me take the first application from the medicine, in the field of medicine, how we can apply our basic science knowledge in the medicine. We can just go through it. The first one is electrocardiogram. That means ECG. You might be familiar with the term. If you have any chest pain or if you feel any uneasiness kind of things will happen just immediately. If you go to the hospital, they will do the ECG, right? This ECG is going to work based on the depolarization and repolarization of the charges. That means the electricity is also very important in order to make our heart to beat, right? Our heart is not going to beat without electricity. So that's why during depolarization, the cells become less negative due to the positive charges entering into the cell. So this is what we call it as a depolarization. During repolarization, the cell becomes more negative and returns to the resting potential. That means in a simple way, this is nothing but the alternative changes of positive and negative charges. That's why this heart is going to beat. So this is very important application. And one more thing, if you look at the bottom picture here, but there will be one picture. That's what we can call it as a stents. When we are introducing the stents because of some formations of the fat or some formation, if there is a blood clot in the arteries or the veins, there must be we have to introduce the technology by using the stents. That stents is also made up of the shape memory alloys. Shape memory alloys is nothing but, let me take one example, nitinol. If you take nickel and titanium, we can call it as an nitinol. That means that remembers its original shape. That means when the temperature is going to change or varies, then that will come back to its original shape and position size. That means before we are introducing that nitinol into that particular tube, that has the different shape and size or structure. When you introduce it into this particular path, then because of the variation of the temperature, then that is going to open up, then that will clear the clotting which is taking place in the basic science principle which we are using during the treatment of heart diseases or when we are taking the ECG. So this is very important point. And as I mentioned, one more is that the X-ray. X-rays are very important. It is a part of our life, because when you go to some hospital, if there is a breakage of the bone, just the doctor is going to tell us to take the X-rays of it. So as we know, Röntgen accidentally discovered it. That's why accidental radiation he has got. That's why he has put the name called X. X means, in mathematics, X means unknown. So Röntgen accidentally discovered X-ray while studying the cathode rays. So accelerated electron produces the X-ray. That is one of the wonderful discovery which has been taken place in the field of basic sciences. So that leads to the applications of these X-rays in the field of medicine. So X-rays are high frequency and high energetic electromagnetic radiation that you need to know, and absorption depends on the density of the material through which it passes. That is we can say absorption coefficient. So when there is a cracks in the bones, and in order to get a picture of it, we need to use the X-ray. This is one of the wonderful discovery which has taken place in the field of basic science. We can see the picture of William Röntgen. So this is a picture, the first picture what he has taken. You can see that. And one more, the applications of X-ray, as I mentioned, X-rays are boon to the orthopedic surgeons, as I said, and X-ray scanning is very much used in airports, industries, other places. So this is very, very important application what we have in our daily life experiences. So X-rays are used in the study of structure of crystals and big molecules. As I mentioned, there's a method in physics called X-ray diffraction. Through the X-ray diffraction method, you can study the structure of the crystal. So in order to study the structure of the molecule, but in case of X-rays, we might be using this hard X-rays. In case of medicines, we are using the soft X-rays. That means the energy differences will be there between that, very simple. So in the study of the structural analysis of the elements or the molecules, these X-rays are very important. As I mentioned, like that, there are many applications are there. So next one is that the radioactivity. So Henry Becquerel was the first person who was introduced or discovered the phenomena called radioactivity in the laboratory condition. So this was, as I mentioned earlier, as X-ray happened. This is also one of the accidental discovery. So the radioactive radiations, which we can call it as alpha, beta, and gamma, but there will be an energy difference in these three kind of radiations. And based on these concepts of radioactivity, we have a number of applications. This is one of the wonderful discovery which has to be taken place in the field of basic science. Nowadays, we are applying that knowledge into the technology. So this picture is the picture of Henry Becquerel and applications of radioactive material. See, what are the things I'm talking about? These are all the discoveries and inventions of the basic science. And these discoveries and invention leads to the effective applications in the daily life experiences of mankind. That's why I'm considering these concepts. So as I mentioned, radioactive isotopes or isotopes we are using in agriculture sector and food processing and addition to pure science research in industries of this radioactive dating is very useful to archaeology and geological in order to study the age of some materials. We are using this radioactive dating. That is a method. The gamma rays and radioisotope are used in the cancer therapy, because you might be familiar or heard about the radiotherapies. So in that field also we are using the radioactivity concepts. And this is one of the picture you can see there is an NMR. This is one of the principles which we are using in the field of medicine. You can see the picture. I'll explain what it is in the next slide. So NMR and MRI. NMR means nuclear magnetic resonance. MRI is magnetic resonance images. We are getting the MRIs from the NMR. So an electron or a proton, this everything in the universe is made up of matter. That means which is made up of a fundamental elementary particles called electron, protons, and neutrons. So this nucleus of these particles behaves like a tiny magnet. That means we can also call it as a magnetic dipoles. These electron, proton, neutrons, nucleuses are behaves like a tiny magnet because of their spin motion. So this will be the advantage for using this or applying this knowledge in the field of medicine. So in the presence of the external magnetic field, because it is also behaves like a magnet, as we know. So if you apply the magnetic field externally, then this proton in a hydrogenous matter align themselves in the direction of the applied magnetic field. So as I mentioned, when this nucleus, when this magnetic dipole of this proton behaves like a magnetic dipole. When you introduce that magnetic dipole to the external magnetic field, then definitely there will be an alignment in the field in the direction of the applied magnetic field. And sometimes a few other in the opposite directions also is going to apply. If those in the opposite directions are made to align in the direction of the field, by external means, we say resonance as it takes place. It's called NMR. That means nuclear means nucleus of the protons, as we mentioned. Magnetic resonance. If you create a resonance by applying the external magnetic field, that is the fundamental physics principle where you need to apply in order to get a magnetic resonance images. These are all the magnetic resonance images where we can see the different varieties. The yellow color is some that indicates some damages or injuries on the brain. So this is one of the wonderful application in the field of medicine. Definitely, if there is a brain hemorrhages or any kind of issues happens where if there is an accident, there will be an injury, a big injury to the brain. Then we can eradicate or we can find the what kind of problem it is through this magnetic resonance images. So definitely in that field it will be very important applications of the basic science principle in order to understand the what the nature. And applications of NMR, as I mentioned, NMR has application in similar field like agriculture, identification of molecules, chemistry. So there are many applications, as I said. So it has a wide ranging applications in medicine, in imaging of brain stem, spinal cord, tumors, hemorrhages, abdomen, kidneys, in many fields we are applying this NMR. But the principle, as I mentioned, is nuclear magnetic resonance. So there are many more applications are there. The pharmaceutical industries in the field of research and dynamics, and very important point is the structure, function, and dynamics of biological important macromolecules can be studied through the NMR. That is also one of the wonderful applications. And one more is that in the field of engineering, also I have mentioned on point, it has civil engineer applications to study the porosity of the soil also. That is also one of the interesting applications of it. So you can see different types of scans are there. As I mentioned, MRI is there, CT scans are there, PET scans, PET scans are there. So I have mentioned some differences between the MRI, CT, and PET here. You can see the different types of scans. One might be X-ray, and ultrasound scan is also important. I'll come to that in my next slide. And CT scan, magnetic resonance imaging, and PET scan. This is very effective PET scan. You can see the third image, where there's a problem, you can see the difference in the images. So some small differences between these three kinds of scans I have mentioned here. That is, what are all the technology they have used, and what are the detect, what that particular scanning is going to detect. I have mentioned in the second row, that is, if you come to the MRI, it is soft tissue, tendon, and ligament brain. Those are all the things we can understand through the MRI. And when we are treating with the cancer, heart, brain, then we will be go through the PET scan. The procedure time is varies. As I mentioned, for MRI, it might be 30 minutes, and CT, it's very less. It is 5 to 10 minutes. And for PET scan, it needs 1 to 1.5 hours. So this is the difference between these kind of scans. So one more interesting factor I would like to mention, one important point in this particular slide. That is, as you know, Sir C.V. Raman was a great mind who has won the Nobel Prize for the first time. He was the first person who won the Nobel Prize from Asia, not only in India. So see, in the year of 1930, now it is 2023, almost 100 years. But we need to, at least I am not telling that we are not capable of getting it, and also our understanding of science is not going to judge based on getting the Nobel Prize and something. No, I'm not telling on that point of view, but what I'm telling is that I am telling the fact. See, because at that time there was no sophisticated facilities, technologies was available. Without any facilities, he has won the Nobel Prize for us. So the young minds, I request our young minds to take this point seriously and work work hard to understand the basic science. Definitely, because the Nobel Prize will be given to the basic science subjects, that is physics, chemistry, and medicine. So that's why definitely, if you do some wonderful research in the field of basic science, definitely it will become the wonderful discovery or invention in the field of, definitely it will be useful for the technology in future too. So the Raman effect is also very important. The great mind, where we can you can see in this slide is Professor Raman. And so application of the Raman effect, you can also, I am not going in detail about the Raman effect and all, because we have many slides to understand the basic science application. Because as you know, why the color changes, why the sky color is blue, and what is the difference between Raman scattering and Rayleigh scattering. There are many the scattering of light is a wonderful subject. You can, and one more thing is, he has started on the institute in Bangalore called Raman Research Institute. There is a department called Light and Atomic Matter Physics. If possible, please try to visit the Raman Research Institute, where you can see the collections of Sir C.V. Raman and what are the things we have achieved. Definitely, you will get a better picture. It's my request for the students also, as well as for the teachers. If possible, try to visit Raman Research Institute in Bangalore. And using Raman effect, it's possible to find the structure of the matter. This is in the study of structural analysis of the molecule. The Raman effect plays a major role. And one more important point application I would like to mention here is that, because we are talking about the applications of science, basic science principles in medicine. So that is during the surgery, the mixture of the anesthesia and oxygen gas flow is monitored with the help of the Raman effect. This is one of the wonderful experiments where we can see the applications of the Raman effect. and it's used in drug and cell biology research and atmospheric physics, aerosol vertical distribution. When we are dealing with atmosphere, we are going to use the applications of the Raman effect, and to study the compositions of all the solid, liquid, and different types of molecular arrangements. In case of solids, liquid, gas, how it's going to distribute, what all the compositions are there. Those you can see through the Raman scattering, Raman spectra. You can see, so you can understand this kind of concept. That is the wonderful applications of Raman effect. So one more interesting applications of the basic science in the field of medicine is endoscopy. Endoscopy is a very interesting topic, because see, the principle what we are using in the endoscope is nothing but the total internal reflection. See, when you incident a light from the rarer medium to denser medium, that means what we can call it as a air medium to glass medium, air medium to water medium. So, based on the bending of light, some amount of the light will reflect back to the atmosphere, and some amount of light is refracting inside the surface, the water, or inside the glass. If you send the light from the denser to rarer, then the bending of the light will be in the opposite direction. So where there is a point, all the incident light will come back to the same medium. That angle, that particular angle, we can call it as a critical angle. So after the critical angle, the total amount of the incident light will comes back to the same medium, the denser medium only. So that is the principle of total internal reflection. Thus, the light is also going to pass in the same way in case of endoscope. That means we are using the very interesting fibers called optical fibers. We are using the optical fibers in order to study though it will send the light, the TIR is taking place inside the tube, and we will gather the information. You can see the picture on the TV monitor, which showing the inside of the stomach. So this is one of the wonderful application of the basic science principle. That is what we can call it as a total internal reflections in optical fiber that will be used effectively in taking endoscope. And one more important application is you might be familiar with the simple microscope and compound microscope, but there are some interesting microscopes called transmission electron microscope. Sometimes we can also call it STEM, scanning tunneling electron microscope. That is also there. But the property what we are using in order to make this instrument to operate is that the wave nature of electron. See, that's what we can call it. That's what we can dual property of matter. That is one of the interesting principle in basic science. So electron is not only a particle, it also behaves like a wave. That is what dual property, that it exists. That means it shows the dual properties. One is the electron is also behaves like a particle. Electrons are also behaves like a wave. The wave nature of the electron will be useful to design the electron microscope. So the pictures what we are getting through this electron microscope are really effective. So that's why the basic invention, the basic discovery in basic science, that is nothing but the wave nature of the electron. De Broglie, you might use some physics people are there, you might be familiar with de Broglie equations. So that means when there is a matter is behaving in both the ways, particle as well as wave, then we are dealing with the matter wave. That is the basic science principle we need to apply in order to get a better images of the electron microscope. So electron microscope, the principle behind it is nothing but the wave nature of the electron. So one more thing, as I mentioned, ultrasound scan, you might be familiar with the sound. What do you mean by infrasonic frequencies and audible frequencies, which varies from 20 to 20 Hertz. So ultrasonic sounds, you can say if it is greater than 20K Hertz, then we can call it as a sound. But you're also familiar with Doppler effect. Doppler effect light is also there, but we are talking about the Doppler effect of sound. That sound is if the object which is producing sound is moving away from us, then you can see the variation in the frequency of the sound. If it is coming towards you, and you can see the variation of the frequency of the sound. That principle also very useful in order to study the many aspects in the nature. So the major applications of this Doppler effect is nothing but ultrasound scanning, abdomen scanning, which you can see in the second picture. So and first one you can see the submarine detection. So these two are the very interesting applications of this ultrasound of a combination of ultrasound and Doppler effect. So this is one of the wonderful concept which was explained by Doppler, which was explained the basis of based on the principles of basic science. So one more interesting fact: shock waves. See, when the speed of the material is greater than the speed of the sound, you might be heard about hypersonics and supersonics. Those vehicles speed, the moving speeds are greater than that of the speed of the sound. That means the speed of the sound in air is 343 meters per second. So if the speed is greater than that value, then it is going to produce new kind of waves, that's called shock waves. That shock waves are very important because that will be used in lithotripsy in the field of medicine. That means, very in a simple language, let me explain it. If there are some kidney stones are there, if they send the shock waves to the kidney stones, it is going to break it down into small pieces, and the small pieces are come out through the urinary tracts. So that is a very interesting application of this shock waves. How do you create the shock waves? As I mentioned, if the motion of the material is greater than the speed of sound, then it is going to give the shock waves. That shock wave will be using in the treatment of the kidney stone. That name is called lithotripsy. So as I mentioned, is going to cut that stones into small fragments. So when it comes to the structure is going to break it as a small fragments, it will come out through the urinary tracts. That is the idea of lithotripsy. So as I mentioned, till now we understood about the importance or applications of, because why I am focusing these concepts is because, as you know, once if you ask any few students, what will you become after completion of your PhD, what you want to become, if you ask this question, definitely either the student is going to tell engineer or doctor. That's fine, but even in order to become an engineer or doctor, the basic principles, the basic science principles plays a major role. One has to have the very fundamental or important knowledge about the basic science principles. So let me explain the applications of science in engineering, where we can apply the basic science knowledge in the engineering. If you take the computer science, as there is the principles of basic sciences. If you take the chemical engineering, as there is a principles of basic sciences. If you consider the mechanical engineering, as there is a base, because without understanding the mechanical properties of a solid, you can't apply your knowledge in the field of engineering. So mechanical engineering. So without understanding the principles of the thermodynamics, you can't able to understand most of the applications of the engineering and technology. Electronics and electronics engineering. Electronics, how the electron behaves in the system, how is going to produce the electricity. This is the fundamental, how the atomic, starting from the atomic structure. Then only if you can't understand the atomic structure in a better way, how we can understand the applications of electricity and magnetism in a bigger way. No, that is impossible. So that's why the basic principles of electricity and magnetism plays a role in the field of electrical engineering. So when you the one principle of basic science, let me say the electromagnetic wave, electromagnetic theory will be the fundamental for the electronics and communication engineering. So that is the Maxwell's equation. Without the Maxwell's equation, you can't understand anything. So that's why in whatever the branch you can take in engineering, there must be a dependency of the principles of the basic science. This is the major point I would like to mention. So semiconductors and computers, as I mentioned, see the materials that conduct electricity more in one direction than in the other direction called semiconductor. See, semiconductor we are using in the manufacturing of most of the circuit. I will tell the reason why. If you take the metals, what will happen is that when you increase the temperature of the metal, there will be a wide vibrations or fluctuations of the electron taking place, which increases the resistance of the system. But in case of semiconductor, it has a negative temperature coefficient. That means when you increase the temperature, then there will be decreases in the resistivity. That is a very important property where we are going to get it in case of semiconductor. So the invention of the p-n junction diode through the better understanding of the semiconductors. So that is having the very huge impact in designing the computers. So As I mentioned, so by using this knowledge, Bruno Rossi in England to study the cosmic rays, he has used this knowledge in order to study the cosmic rays, and Rossi constructed two kinds of circuits. In the beginning, that's what I'm telling. Later only, they have designed the computer and all. So the Rossi constructed the two kinds of circuits. That's what we can call it as a coincidence and anti-coincidence circuits. You can see the one of the picture of it, how they can design those kind of circuits. And this the pictures. So this coincidence circuits is nothing but AND gate. We can call it AND gate, and anti-coincidence circuits are called OR gate. So these became the basis of creating binary circuits for the computer. So as I mentioned, this foundation concepts in the basic science helped us to design the wonderful computers later. So a research in physics led to the development of the computer. So the next one challenge, what I'm mentioning is that the nanoscience is the man behind this idea. That means Richard Feynman, one of the great mind, great scientist, great teacher, was awarded the Nobel Prize in the year of 1965 for his contribution in the field of quantum electrodynamics. So he was the first person who talked about the nanoscience and technology. He made a statement called, "There is plenty of room at the bottom." This is a wonderful statement where he speculated on the possibility and potential of nano-sized materials through this statement. Let me repeat it: there is plenty of room at the bottom. This is the initial statement which was made by Richard Feynman. So, as I mentioned, the nanoscience, the branch of science and engineering devoted to designing, producing, and using the structure, devices, and systems by manipulating the atom's molecule in the nanoscale. So, what will happen according to the quantum mechanics is that when you go to the deeper level, the behavior of the particles will be different. It will be not similar as when it is in the microscopic scale. So those behavior of the materials when it is in the state of macroscopic scale and when it is in the status of microscopic scale will be different. So that we need to understand through this nanotechnology. So nanotechnology, you can see in the nature, as I mentioned, carbohydrates prepared in the plant leaves, because carbohydrate is going to prepare in the plants leaves are made atom by atom from carbon dioxide and water using sunlight. This is also happening in the nanoscale. This is what I'm mentioning is the where we can see the nanotechnology in nature, and in the conversion of food into the energy in our body, very little wastage occurs. Biology is nanotechnology in perfection. So in this application, also when it is converting, the food is converting into the required energy for us. At that time, also we can see this nanoscience, and the materials can be made super tough or super light when use nanotechnology. This was a very much required for the mankind. Those are the things and through technology. And one more important point from the science is the first cell where we can see in the development stage of things. So they have the ability to keep very important pluripotent stem cells from the skin cells of mice. This is already done. So this is one of the challenges. I'll tell you what you can do if you understand this idea in basic science. So this challenge is to understand the treatment for human disease like diabetes, Alzheimer's disease, Parkinson's disease. So if you understand these terms, basic science in a proper way, definitely there will be exposure. You can come with many wonderful ideas. So there is one team from Pune, Chaitanya Therapy Center. They already patients for diseases like brain hemorrhages, spinal cord injury, like that they are treating by using these ideas. So one question is that can we do this from the skin cells? This is a challenge you need to think of. And one more thing is the fusion energy. We know that we are that because of the light. How the star is going to emit the light, that is nothing but the nuclear activity, right? So that's why enormous produced, that is through the nuclear fusion. right? That is the nuclear fusion. So can we make use of it? The efforts are made to replicate this process inside the laboratory. That there are some drawbacks, definitely, definitely some challenges are there. That's why I have mentioned find the technology, or if you find the technology where you can
Any problem, sir?
hello. Hello.
Sir. Audio.
Am I audible now?
Yes, sir. Yes, sir.
Sorry. Now is it audible, ma'am?
Yes, sir.
Hello.
Yes. Yes, sir.
Okay. Okay. 1 minute, but I'll share my. There might be some. Okay. Just I'll share my presentation. Is it not visible?
No, sir. Now it's coming, sir. Yes, sir. We are able to see.
Okay. Is it visible, ma'am, now?
Yes, sir.
Okay. Okay. So as I mentioned, the nuclear fusion. So if we get the technology where we can make the replicate to this process inside the laboratory condition, then definitely it will be a very wonderful invention or discovery in the field of science. Because see, we are getting the energy from the sun, but we don't have the enough technology to store all amount of energy which is emitted by the sun. So that's why this is one of the challenges in the future. So heavy hydrogen found in this is one of the very interesting fact. Heavy hydrogen heavy hydrogen in the seawater can also be used to produce the fusion energy. We have to make this we have to make use of this in an effective way, and the fusion energy production will be highly pollution free and will produce a no sooty pollutant. So this is one of the very good applications of it. Definitely some drawbacks or demerits are there, but you have to overcome it in order to apply in our daily life experiences. And one more important is the superconductors. Superconductors, you might be knowing it. Conductors, which is with those materials are heated electricity. It's better materials which shows the properties of conductivity. We can call it conductors. But superconductors, the resistivity will be approximately is equal to 0. That one we can call it as superconductors. But Japanese scientists have found that in order to, let me make one more statement. In order to achieve that superconductivity state, we have to increase the temperature in order to we have to decrease the temperature in order to slows down the fluctuations which is taking place in the electrons. So Japanese scientists found that a new substrate formed with the combination of the lanthanum, oxygen, iron, and phosphorus has no electric resistance at 4K temperature. That is superconductors. That means that this is one of the discovery which has to be showed by the scientists, and they have reached this superconductivity state. The resistance will be approximately equal to 0 at 4K temperature. When some of the oxygen atoms are replaced with the fluorines, it's superconducted at 7K. So a low temperature, room temperature superconductor is also one of the future. We know about superconductors, but room temperature superconductor, if you make a material to behave like a room temperature superconductor, definitely it has a huge application in our daily life experience. So there are some I have mentioned some discoveries about superconductors with the different temperatures. Following similar techniques, Chinese have produced compounds that superconductor at 57, 56 Kelvin, and between some of them have done it with 35 to 138 Kelvin. 138 Kelvin. So if you do that, this is one of the challenge what we have in the basic science. And one more point is that that is nothing but the new drug and new materials. For that we are using the powder metallurgy techniques. So by using that, that mimic human bone. So these are all this is from the material science field. So this helps in many applications in the manufacturing of drugs. So one or 2 points just I'll explain. That is, this is all used in as bone or dental implants. See, if you done this, the challenge is what we have in the field of material science. So if you've done it, these are all can be also used as bone or dental implants. And synthesis of new drugs, a challenge in chemistry. So definitely, in order to overcome those challenges, this discoveries are need to be happened. What this is all about some applications and what applications of the basic science in the field of medicine as well as in engineering and also in the technology. See, these are all the very fundamental principles we need to understand in order to get a better picture in the application part in engineering, technology, and medicine. So these are all the very required concepts. But in my next few slides, I'm going to talk about some interesting facts in the basic sciences. So first one is electromagnetism and light. So what is the light we are seeing? It is nothing but the electromagnetic wave. That is, as I mentioned. See, if the electric field and magnetic field is continuously changing with respect to time, it will give the light in the another direction. So these 3 directions are mutual perpendicular in general. But as I have mentioned many times to my students also, for the electric circuit or televisions or radio, no, not like that. Electricity, you can't see without electricity, you can't think without electricity, your art is not going to beat without electricity, muscle contraction need electricity, and everything needs electricity. So that's why in order to do like this, you need electricity. So that's why that's what I mentioned in the beginning slides. So to get a big picture of most of the answers in the TV, car, like that only. But electricity or not, we can't think without electricity. Even we can't think. That is that kind of better understanding we have to have. We have to get about the electromagnetism, that is electromagnetic theory. So that plays a major role, because one of the person I would like to take, his name is Michael Faraday. He has explained the concept of lines of forces. He explained how these lines of forces are forming in it by using the wonderful diagram, right? Without any mathematics. He has explained it through the imaginary lines of forces. So this is electromagnetic theory is one of the very much interesting, very interesting theory, where we need to understand many miracles which is happening in the nature, because light, without light we can't see anything, right? So that's why this is one of the very interesting topic in science. And one more thing is the theory of relativity. See, when theory of relativity explained by Albert Einstein in the year of 1905, he has given 2 theories. One is special theory of relativity in the year of 1905, and general theory of relativity in the year of 1915. So this was the theoretical explanation. But till today, getting the Nobel Prize. See, that shows the importance and the effectiveness of the theory of relativity. Let me take one example. In everyday life, we are using the GPS, Global Positioning System. Around 24 satellites are there from the United Nations, which is moving with the altitude around 24,000 kilometers with the speed of 12,000 to 14,000 miles per hour, kilometers per hour. So those satellites are giving the signals. But in order to get the best and exact position, in order to get the accuracy in the position system, we need general theory of relativity and special theory of relativity. Because the general theory of Newton talked about and explained about the law of gravitation, but he didn't explain where that gravity comes from. That explanation was given by Albert Einstein in the general theory of relativity. See, one point I would like to mention: if the speed of any object is close to speed of light, then the time ticks slow for that object. The time moves slow in that object. That is what we can understand through the special theory of relativity. And if the gravity is also going to affect the time, because the time, if something is moving away from the earth gravity, then what will happen is that the time is going, it ticks slow. The time moves slow when it is on the, when you compare with when it is on the earth. So those were the concept was explained by Albert Einstein. So this wonderful theory is going to apply in the field of global positioning system. So that's why As I mentioned, nowadays also the wonderful research are going on, the consequences like gravitational waves, many things are there in this field. So it is not an easy task to understand this theory of relativity, but it is one of the fascinating and wonderful subject where you can see because he has explained in a theoretical way, but nowadays we are using that knowledge in applying in the application of technology. One of the best example is GPS, because when the satellite is moving in the space, definitely there will be a time difference between the clock which is there on the rocket and the clock which is there on the earth. That's why we are not using the normal clock in the rocket, that we are using the clock called atomic clock. So this time difference definitely make a big difference. So that's why in order to overcome this problem, we are going to identify this time difference by through the general theory of relativity and special theory of relativity. So definitely it is one of the interesting theory in the field of science. And one more, most of the people can say, most of the student can ask, sir, what is your opinion about the extraterrestrials or unidentified flying objects? This is definitely one of the expected questions we can expect from the students community. So see, I will say, I can't say yes, there's an extraterrestrials or no, but I will say what are the possibilities, what are the parameters you need to consider in order to say yes, there is a life. So I would like to mention 3 points. One is the liquid water, because it is a universal. If you see a place, for example, if you go to some other objects in the space, so in order to study whether there is a life or not, you need to study these 3 things basically. The first one is the liquid water, because it is a universal solvent, will be the key factor in creating life in the universe, because it dissolves all kind of elements. So that's why if there is a traces of liquid water, yes, there might be a possibility of extraterrestrials. And next one is the carbon. That is, a carbon is a very important element, because it's like a component in creating life, because it has 4 bonds and has the ability to bind to 4 other. So it forms the elements, some other elements. So carbon. So one of the experiment which has to be done in the year of 1953, that experiment we can call it as a Miller experiment. In that Miller experiment, what he has done is that he has taken the combination of ammonia, methane, and other toxic element. So he has mixed it, and for that mixture, he has supplied some small amount of electric current. After some time, you can see the changes that forms amino acid. See, amino acids will give the proteins. Proteins means there is life. So this is a wonderful experiment which has to be done by Miller in the year of 1953. That is through the carbon compounds. As I mentioned, he took the mixtures of methane and the ammonia. So that's why if there is a traces of carbon, yes, there might be a possibilities of life. And another one is the wonderful concept called DNA. That is what we can call as a self-replicating molecules. That means the fundamental basis of life is a self-replicating molecule called DNA. If there's a trace of DNA, definitely there will be life. So these 3 parameters we need to study in order to find the life in other planets or other celestial objects. That is a liquid water, carbon, and the DNA. And one more interesting fact in the science is the quantum computers. Nowadays, the computer what we are using, that's all called classical computers. So there is a one more computer. It is not supercomputer. It is a quantum computer. Quantum computer is one of the wonderful invention in the field of basic science. Now we don't have the quantum. We are not using quantum computers in India nowadays, but it is the future. That means if you quantum computer will be available in the society, definitely it has a huge impact in the mankind. As I mentioned, it will be having the huge application in the computation field, dimensions, combinational, many fields. As I mentioned here, renewable energy in the field of material design and simulations, carbon capture management, everywhere, quantum cryptography, many things are there. So that's why. But as I mentioned, the classical computer, it will be operating on the basis of 0 and 1. Only either off or on. Only 2 possible states are there. But in case of quantum computers, it lies in between that. In quantum computers, we can call it as a qubit. In case of classical computer, we can call it as a bit. This is one of the challenges what we have in our nation. So we have to look into this kind of concepts in order to make our country proud in the field of science and technology. That is applications of quantum computer. Now the theoretical research is going on in an effective way in our nation, and definitely there is a good development in future too. So if anyone is interested, so please look into it. It is a wonderful subject, that is the quantum computers. So, and solid state physics, it is a fundamental. That's it. If simply I'll take one example. Before, when we are driving the car, we had a steering. In order to take a U-turn, you have to rotate 5 to 6 times in order to take the U-turn. But nowadays, if you rotate like this, immediately it will turn, right? Because that is because of the development of the magnetic sensors, right? That magnetic sensors is development that is because of the principles of the solid state physics. So solid state and crystal physics is a wonderful subject. So where you can study the structural analysis of any molecules or any elements, or in order to design the wonderful materials which will be helpful for the application of the technology. This solid state physics plays a major role. So these three people you can see for example, if you consider integrated IC chips, you can see in your mobile phone, TV, everywhere. IC, how this IC is made up of? This integrated circuits are made up of. But if you consider the millions of transistors, if you take, you can design one IC, integrated circuit. So transistor, who invented this transistor? These three people invented that transistor. In the year of 1948, these three, Bourdin, Bredin, and Shockley, these three people have invented the transistors, and that is the foundation for the development of the integrated circuit. Then after the integrated circuits, we have the VLSIs. VLSIs is very large integrated circuits. So that's what we are using in all our electronic devices like mobile, computer, and all nowadays. So this is the foundation for basic principle in order to design all these computers and mobile phones. And biomimicry engineering, this was a very interesting subject. That means if you see the nature, as I mentioned in my first slide, if you observe the nature, you'll come to know many interesting and fascinating things. So if you understand it, you can apply the same principles in the daily life or in the technology. So you can see the first construction, you can see the man-made technology, and another one is the technology which has to be designed by the nature. You can see the first one in the construction part, and the energy in the way well-edged fence. You can see how this energy, the structure can be designed through observing the nature or animals. And the medical field, you can see the differences, how the structures of the shark is made up of, and that has the antibacterial surfaces. You can use it technology anywhere. And for the sonar, one more I would like to mention. If you take some leaves are there. If you put some drop of water, what will happen? It flows down. In the same way, that's what we can call it as a, for the designing the surfaces of the solar panel. If you use it, definitely it will self-cleaning property we can design. So like that, there are many examples. What I've seen, mobility, Kingfisher's beak, see low resistance train design with some same principles. So self-cleaning, as I mentioned, self-cleaning properties of the solar cells. So the same concept, they have used hydrophobic paints. They're going to do it for the buildings. So that's why I mentioned, once you observe the nature carefully, you will come to know about many things which is there in the nature. So DNA, one more important thing, as I mentioned, is DNA. Earlier also I talked about it, but DNA, why I have introduced a special slide for this is because DNA was first the picture. You can Rosalind Franklin, you can see she has used the method called X-ray diffraction. This is the basic principle of basic science. So actually, one of the famous book written by Erwin Schrödinger. Erwin Schrödinger was a famous physicist who has given the equation called Schrödinger equation in quantum mechanics. He has written one book called What is Life? That book is for biologists. So Watson has read that book and inspired by that book, and he has discovered the structure of the double helix structure of the DNA. Actually, Watson was a biologist. Crick was a physicist. He was a physics scientist who helped him in order to get a better double helix structure picture of DNA. So that's why it is interdisciplinary. So that's what I would like to suggest for all the students and teachers community. We are not supposed to differentiate. This is physics, this is chemistry, this is biology, this is mathematics. All comes together. So nothing wrong if a physics teacher or physics student is going to understand concept in biology. Nothing wrong if a chemistry student or teacher is going to understand the concept in mathematics. Everything is required for us. That's why it is interdisciplinary. It is multidisciplinary. That means it is better to get the knowledge of all the concepts. And this is the problem what our engineering students are doing. They are not interested to understand the principles of the basic science. So I also request the engineering faculties to create the interest in students to understand the principles of basic science in order to give a better understanding about the technology which is existing in our daily life. That's why this is a very important point. And one more thing is there is only two things in the universe we can call amateur. The first one is radio and the one is astronomy. So amateur radio and astronomy. So this amateur radio, I would like to mention one important amateur astronomy. In order to become an amateur astronomer, you want to be, you no need to do the PhD or masters and all. Amateur astronomer, just through your observations, you can do that. It is a hobby, right? In the same way, these two comes together, amateur radio and astronomy. So these two are very interesting subjects. And one more, because through the amateur astronomy, there are many wonderful discoveries has been take place. So that's why amateur radio, I would like to mention one point. You might be familiar with the ham radio. In the picture, what you are seeing is the or the program which we have conducted for the Scouts Guides students in Mysore. The program is on ham radio. One of the person who is there who explaining the concepts of amateur radio is Mr. Mahesh MB. He is also one of the, he is having the license from the Ministry of Telecommunication, AM license. So I request the minimum age in order to get a ham license is 12 years. If you are 12 years old, as you can get the ham radio license. So you will come to know how we can generate a radio waves, how we can send the signals, how we can receive the signals. During the disaster management, if all the network fails, there's only one way, that is a ham radio. So that is one of the very important hobby. That's what we can call amateur radio. You will come to understand how to use the electrical components in an effective way. Simply, definitely, I assure you that in order to understand the usage of the electrical component in the technology part, you must become an ham. Otherwise, definitely you can't, because here you are doing the experimentation. So ham radio, amateur radio will create the platform to you to get the exposure in the field of communication. So that's why in many places we are using disaster management, we are using amateur radio and all. So that's why, as I mentioned, Ministry of Telecommunication will be give the license even for the 12-year-old student. So you have to create the interest. You have to, if you know how to design my antenna, how to send the signals, how to receive the signals, how the transmitter works. So these are how the transmitter, how the receiver works. Those are the things you are going to understand. This is the experimental understanding of the electrical component. So if you want to learn on this basis, just to try to become a ham for that. So this is one of the picture where we have conducted the wonderful program on amateur radio in Mysore. And starships, this is the last interesting fact I would like to mention. Starships, see, for example, after 10 billions of years later, if the sun is going to collapse, what will happen? The entire solar system is going to collapse. So then what is our future? If the if the generation continues, if the age of the sun is going to increase, as I mentioned, after 10 billions of years, what will happen? Definitely the sun is going to collapse and it will become the white dwarf. So at that time, what is the option for us to go other than the solar system? That we have to think from right now. That is also one of the challenges, right? So simply, we are fine now. After 100 years, we will die. So that's fine for us. No, we are not think like that. We have to give some better platform for the future generation too. That's why where we need to go if the Earth is going to end. Solar system. For that, we need to go to some other celestial object that we need to find out. That is also one of the challenges. But how we can go? That is through the starship. That is through the rockets and all. But what is the speed? For example, if you want to go to nearest star for us from the sun, around it will take 70,000 years to reach. We have the 40,000 km/h around that speed range what we have nowadays. But In order to, with that standard technology, what we have nowadays, the number of years you need to reach that nearby star is 70,000 years, right? So how we can improvise? That is also one of the challenge you need to think of. So there are different types of engines. The research are going on that based on the solid, that the specific impulse. The specific impulse is nothing but the force acting in a short interval of time. That is very important. So the thrust, in a simple term, we can call it thrust. So there are the designing of the different kinds of racket where we can increase the speed of the racket, that plays a major role. So that is, as I mentioned, in the picture, what I have mentioned is from the rockets of our great ISRO. But the concept what I have mentioned below, the rocket engine plays a major role. It might be solid fuel rocket. There are, see, the specific impulse value, if you see, when the nature of the rocket engine changes, if you come to the nuclear fusion rocket, there are different types of engines, right? Antimatter rockets. This is all the future we need to think of. Then if you think of the specific impulse value is also going to increase. So if you design a rocket through the science, principles of science, nuclear pulsed rockets or antimatter rockets, this is the principles of science. By understanding the basic principles of science in a better way, if you try to increase the specific impulse value, we can reach the nearby galaxy in 1 year, right? So that's why definitely it will become helpful for our future generation. This is also one of the challenges what we have in our future. And some exposure program, if there are some PUC students or school students are there, it will be useful. There are some schemes which is given by the government of India and Karnataka. I think there are some exams called KVPY and all. And one more Olympiad program I would like to mention here that is conducted for the school and college students. There are many Olympiad competitions are conducted by many private agencies. I request all the students to don't get into it. There is only one Olympiad which is conducted by Government of India through the Homi Bhabha Center for Science Education. That is their Mumbai. That is the only one authentic Olympiad what I know, which is happening, which is taken place in our nation. That is what we can call International Olympiad Program by Homi Bhabha Center for Science Education. It is one of the branch of Tata Institute of Fundamental Research. So here there are different stages. For example, National Standard Examination, Indian National Olympiad, Orientation cum Selection Camp, and Pre-Departure Camp, finally International Olympiad. More than 100 plus countries are going to participate authentically. That means this is the authentic Olympiad. So here you no need to pay a single rupee. The government is going to taking care of it. So that's why try to crack this kind of Olympiads. Definitely it will give the exposure. And in order to crack this Olympiad, you have to have the both experimental as well as theoretical knowledge. So if you are interested to get into the Olympiad, try this. That's just my suggestion. There are some different steps are there. So if you want to, I have included some slides of it. So if you want more information, please visit Homi Bhabha Center for Science Education. Because the first stage of examination will be conducted by Indian Association of Physics Teachers. Every details will be there in their website. Please visit it. There are different types of Olympiad, National Standard Examination, astronomy, in biology. For school student, it will be as a junior science Olympiad. For the PU students, it will be as a subject wise, physics, chemistry, mathematics, biology, like that. So there are some different criteria. Please visit the website. These are all the information you are going to get it. So see how we are going to form the teams in the different subject you have mentioned in this picture. So in the era from the 1998 to 2018, in this Olympiad, 472 students have won the medals. In that, see, most of our gold medals. So in general, our Indian students are performing very well in the international Olympiads. So it is one of the young scientist program which will be conducted by Karnataka Rajya Vignan Parishad every year. Definitely, if you participated, because as I mentioned, in order to inculcate or create the interest in basic science, you have to get the exposure. Where you can get the exposure? You can get the exposure through this kind of programs. So opportunities, if any students are here, what you can do after your PUC and all, you can see this engineering, medicine, degree, teaching, and other. If you go to the engineering, there are some courses, BTech courses. There are different types of branches are there, and paramedical is also there. After completion of the PUC, you can also get to the paramedical courses, and you will be having them MBBS courses, that is nothing but the medicine. In the BSc also, there are wonderful courses are there. Where if you can also take the combination of chemistry, mathematics, physics, mathematics, and electronics, BMBT, biochemistry, microbiology, food and nutrition. Wonderful subject. These are the wonderful basic science subject. Please get into that kind of fields. So you can see at the bottom part, BSc, you have the BSc, many horticulture is there, and home science is there, biochemistry is there. Many concepts are there. Even BSc agriculture is there. See, even in agriculture, there are many concepts are there. So University of Agricultural Sciences, UAS, is there in Bangalore in the name of GKVK, and Agricultural Science University is there in Raichur. It is there in Shumaga. It is there in many places. We have the agricultural universities. So get into the this kind of courses in future. Okay, next, STEAM education. Just this is my very important concept, but just in a quick manner, just I'll go.
Abhishek sir, sorry to interrupt. Time is running up. Please.
Yes, okay, ma'am. Just wait, within 5 minutes, I'll wind it up. Okay. So STEAM education. So STEAM education is nothing but the science, technology, engineering, arts, and mathematics. So it improves the critical thinking, problem solving, communication, and creativity, innovation. So the science models, you can see technology, engineering, art, and mathematics. Every skill is very important. Tinkering lab, which gives exposure waste, less sort of waste. So this is all the concept you can see. These are all the airplanes which is built by the students. So 3D printed models, which creates the artistic characters, properties in the students, is the ham radio, as I mentioned. So one example I would like to concept, when we are telling the story to the students, you can also tell the science behind it. For there is a primary school students, you can explain, after telling the story, you can explain what is sinking and floating. If it is a high school student, you can explain what is density and mass. This is what are the stories we are telling, you find the science in that. This is one of the example. So this is a brief information about our work, what we are doing through our Science Foundation, science towards students, and some competition for the students. This is some visits, ham radio, and astronomy, and there are some STEAM camps are there. So this is the work what we have done through our Science Foundation. So this, as I think Triactu is also of the official space tutor of ISRO, I hope. So in the same way, we also have the affiliation through ISRO, space tutor. Under that only we are conducting some activities. If anyone is interested to visit our center, please visit our center, one in Mysore, Chamaranagar. And this is the last 3 slides. It's very important. Please listen, whether you are a teacher, student, or any science communicator. I request, see, this was development of scientific attitude, scientific cultures, and the scientific literacy in the society. These are all the very important point. That is nothing but we had the great scientists like P.C. Ray, J.C. Bose, Meghna Saha during 20th century. But at present, we have very limited number of international known scientists, because the situation with these 200 years is unimaginable. It already this rise has been already showed it, but I will show that. Okay, the proper why the science and technology is very important is because of this. Prosperity requires economic growth. Economic growth requires the development of science and technology. Technology growth requires a strong base in basic science research. So if you see the developed country, America and Europe, China, the development advancement in the science and technology is the main foundation for them. You can see this in this graph. This shows the number of engineers and scientists per million people. Where we have to search it here. We have to search it here, where we have seen this picture. So that scientific literacy, scientific attitude has to be increased. So if definitely this slide will be useful. This was the top research institute in India. You can just make a note of it. If you want to become if you want to do some research in future, just get into this kind of research institutions. And if anyone hates science, then I hope you have probably learned it from a wrong teacher. With this, I would like to conclude my session, because science is a vast subject. It is very difficult to say it, explain it in 1 hour. Even for me, 1.5 hours, 2 hours is not sufficient. But within this, I actually have planned to explain this idea within 1 hour 30 minutes. Sorry, I have exceeded. No, 1 hour 20 minutes I have explained it, because 5 minutes for any interactions or any clarification inquiries are required. I can very happy to interact. And with this, I would like to conclude my session. As I mentioned in all my slides, please get into the science education research. You have a lot of opportunities and exposures in this area, and this discoveries and inventions of science will leads to the development of the technology in our nation. With this, I would like to conclude my session. I would like to thank the team of Create Reactive for providing this wonderful platform to express my ideas. Have a great day. Thank you, Vanita.
Thank you, sir. If any questions, you can raise your hands. Any questions? Shastri sir, any comments?
Not only questions, if you want to give any suggestions or inputs, definitely I will be happy to
No, I'm Srinath here.
accept
It was a
it.
very comprehensive talk. Good that one is collective information is available at one place to listen for the students. But my question is specifically to your area, Chamarajnagar. I
Yes, sir.
understand there people joining to the BSc and the science courses. Of course, it is in general overall reduced across the Karnataka. But in
Yes, sir.
Chamarajnagar, many of my friends are professors there. They find that there is a less attraction to the BSc. What is your experience and how you are motivating through gravity science?
Sir, actually, that is the problem. Not only in Chamarajnagar, everywhere, sir. Because the problem is that attitude, that aptitude, we have to inculcate during the school and in the college days, sir, PUC. See, one more very important drawback is that when the student is studying in PUC, all the educational institute, what they are doing, sir, as you know, they are just training the student, because we are training the students. We are not train them to think. We are training the students to get into the crack the CET examination or NEET examination or JEE examination. That is the concept what we are going to give to the student on that particular level. So in every institution, sir, if you see nowadays, along with the academics, there will be an additional coaching. The institution itself is going to give the coaching for NEET and JEE, CET. So in the beginning itself, if the student is coming to get the admission in any PU colleges, the first thing they are looking into and the first thing the institution is going to tell, that is about the NEET and JEE coaching. But no one is talking about the opportunities what they have in the field of BSc and all. This is happening in all across the states and not only in Chamarajnagar. And one more important fact is that even for the engineering students, once they are getting to the engineering studies, in the first year only they are studying the science, physics, chemistry, and mathematics. They are studying physics, chemistry, mathematics as the basic first year subjects. They don't know the importance of it. How these three subjects are having the huge impact in the applications of the technology. So in order to overcome this problem, what we are doing is that we are giving the career guidance in the field of basic science research. So why this? That's what in my presentation also, sir. If you see my presentation, most of the slides are related to the applications of basic science principles in medicines and applications of basic science principles in engineering. So this kind of concept, this kind of inputs are going to give the better understanding about the importance of basic science. So on that manner, we are conducting many awareness program for the student, and also we have collaborated with PU Institute to give this exposure to the students.
Thank you.
Thank you, sir.
Shastri sir.
Yes, there were too many facts, to digest, in the lecture. So it would have been better, if we had concentrated on one particular kind of a thing. I can understand, the pressure, for the speaker, to tell, everything, regarding science. But it became a kind of a mixture. Okay, the facts were, very much good, but the major thing, what I feel, as a science communicator is that, we have to definitely attract people, to science and mathematics, especially. If we don't do it, perhaps, the India itself, is doomed, regarding that. Okay, let us take it up, really what I expected was the problems, what we are having, in the science communication aspect, as such. So that, was missing. Okay, let us try, sometime, we should, go forward.
Thank you, sir. Okay.
Thank you, sir. As
Any
you
more
said,
questions?
one more comment I would like to mention. As you said, actually, my intention of my lecture is to explain about what is the basic science principle and opportunities, challenges, what we have in basic science education. So when we are talking about the science communication and all, as you mentioned, it is that's why that is not there in my presentation. Science communication. I am not. I don't have that kind of idea in my lecture. That means before also I was not thinking about giving the lecture about science communication. So it's purely about applications of science in engineering and medicine, not about science communication. That's why I missed that particular science communication part.
Okay. Sir, time is running out. So we are ending here. On behalf of all, I could like to extend my thanks to Mr. Abhishek sir for accepting our invitation and for being with us today. I like to thank all our participants for being with us. Let us continue to celebrate and support science education. Thank you, one and all.